Hi there. In our lesson for today, we are going to explain Chapter 5, Lesson 4, Part B, Calculating an Area Between Two Graphs. Calculating an area between two graphs. If f and g are two continuous functions so that f of x is bigger or equal to g of x over the interval AB, which means if the graph of f of x is over the graph of gx at the interval AB, then the area of the region bounded by the graphs of f and g, the two lines x equal a and x equal b, where a is smaller than b, is equal to a, which equal integration from a to b, f of x minus g of x dx. But if the graph of gx is over f of x at interval ab, then a is equal integration from a to b, g of x minus f of x dx. To find the area between two graphs, follow this step. Step 1. Solve the equation f of x is equal g of x and find the value of x. Let this value be x1 and x2. Step 2. If there is no interval given, then the value of x is interval of integration. A is equal absolute value for x1 integration from x1 to the x2 f of x minus g of x dx. Step 3. If interval AB is given and the values of x not belong to this interval, then the area is equal absolute value of A integration from a to b f of x minus g of x dx. Step number 4. If interval AB is given and the value x1 belongs to this interval, then we take area is equal from a to the x1 and from x1 to the b. Let us take the first example. Find the area of the region bounded by the graphs of the two functions f of x is equal 8 minus x squared and gx is equal x squared. First of all, let us find the intersection between f of x and gx. Let f of x is equal g of x. Then 8 minus x squared is equal x squared. By taking 8 minus x squared from left to the right, so it becomes x squared minus 8 plus x squared is equal to 0. X squared plus x squared is 2x squared minus 8 equal 0. By taking 8 from left to the right, so 2x squared is equal 8, and dividing by 2, x squared is equal 4. By taking square root for both sides, so it becomes x is equal plus or minus 2. So we have two value of x, minus 2 and plus 2. Because we haven't any interval at the example, so we take the integration from x equal minus 2 2x plus 2. Do not care which one is bigger, as we can see that f of x is bigger than g of x because f of x is over g of x. So we can say f of x minus g of x. But don't think about that, only put absolute value. So then the area is equal absolute value integration from minus 2 to the 2 f of x minus g of x dx. F of x is 8 minus x squared minus g of x is x squared. Simplifying, it becomes integration from minus 2 to 2, 8 minus 2x squared dx. By taking the integration of 8 is 8x minus the integration of 2x squared is 2 over 3x cubed. And now replace 2 in place of x the first time, so it becomes 2 times 8 is 16 minus 2 cubed is 8. 8 times 2 is 16 over 3. Minus, and now we are replacing minus 2 in place of x. It become minus 16 because minus 2 times 8 is minus 16. 2 cubed is minus 8. Minus 8 times 2 is minus 16. Minus 16 times minus is plus 16 over 3. And simplifying this one, it becomes 64 over 3. 64 over 3. This is the area between these two graphs. Check it out. Find the area of the region bounded by the graphs of the two function f of x is equal minus x squared plus 2 and gx is equal x squared. Let us first of all finding the intersection between these two graphs. Let f of x be equal g of x. And now f of x is minus x squared plus 2 is equal 8 squared. By taking minus x squared plus 2 from left to the right, it becomes x squared plus x squared minus 2. So it becomes 2x squared minus 2 is equal to 0. By dividing by 2 and taking the square root of both sides, we get that x is equal plus or minus 1. Because we haven't any integration, any interval, we can take integration from minus 1 to the 1 for f of x minus g of x inside the absolute value. And now replacing the value of fx and the value of gx, so it becomes absolute value integration from minus 1 to 1 for minus x squared plus 2 minus 8 squared. Simplifying, it becomes absolute value from minus 1 to 1 to minus x squared. Minus x squared is minus 2x squared. And now take the integration. The integration of 2 is 2x, and the integration of 2x squared is 2 over 3x cubed from minus 1 to 1. And now replacing 1 times 2 is 2, 1 cube is 1 times 2 over 3 is 2 over 3, minus 1 cube is minus 1 times 2 is minus 2, and it becomes 2 minus 2 over 3 plus 2 minus 2 over 3, it equals 8 over 3. 8 over 3. Example 3. Use integration to evaluate the area of semicircle of a radius r. This is the graph of the semicircle when its center is over 0, 0, or it is 0, 0. And now, first of all, we must find the equation of this semicircle. To do that, First of all, we must take, as you know, that the equation of circle is y square plus x square is equal r square when its center is 0, 0. And now we must find y, so y square is equal r square minus x square. And now by taking the square root of both sides, so y is equal square root of r square minus x square. This is the function of the semicircle. F of x is equal square root of r square minus x square. This is the function of the semicircle. Area of circle is equal pi r square. Because we have here semicircle, then the area of semicircle by dividing this one by 2. So area of semicircle is equal pi r square over 2. And now we want to prove this one, to prove that the area of semicircle is pi r square over 2. To do that, we must first of all take this part and this part. That means take the integration from minus r to the r. So area is equal integration from minus r to the r, square root of r square minus x square. And now, as you can see, that the part of the left side of y is equal the part of the right side of the y. So we can take only one side and multiply it by 2. So area is equal 2 times from 0 to the r. From 0 to the r, square root of r square minus x square dx. And now, to find this integration, we must use substitution. First of all, let us take a point over the semicircle. This point be x, y. And now draw a segment from 0, 0 to this point. And from this point, this segment is equal the radius, which is r. And now from this point, draw a vertical over x axis. This vertical and this angle is, let b is equal to t. And here it is x and here is y. And now cosine of this angle t is equal x over r. And using cross multiplying, it becomes x is equal r cosine t. And now here, in place of x, we're using r cosine of t, cosine of t. And now let x be equal r cosine t. And now take the derivative of this one to find dx. Dx is equal r, the cosine t is minus sine t dt. And now, because we need x squared, so we must find x squared from this equation. The x squared is equal r squared cosine square t. When x is 0, so this segment is coming here, and the value of x is the value of angle is become pi over 2 because the here the pi over 2. When x is r, then t is 0. And now we are substituting this value in this integration. It becomes a is equal to integration from 0 in place of 0 when x is 0, so t is pi over 2, and if x is r, then t is 0, square root of r square minus, in place of x square we are replacing r square cosine t square t, cosine square t. Outside, in place of dx, we are using minus r sine t dt. Changing the interval from smaller to the bigger, so it becomes from 0 to the pi over 2. This one is become minus, and now minus sine t dt, and now minus time minus is positive 2r square, because we have taken out from here r time r is r square, and minus time minus is 2r square. Integration from 0 to the pi. Here 1 minus cosine square is sine square t, and now simplifying, area is equal to r square, integration from 0 to the pi over 2, and now square root of sine square is sine times sine in sine square t dt. And now we are continuing, area is equal to r square from integration from 0 to the pi over 2 sine square t dt. And now, because or since the sine square t is equal 1 over 2 1 minus cosine 2t, we changing this one or substituting this one. Area is equal to r square integration from 0 to the pi over 2 1 over 2 1 minus cosine 2t dt. And now, by taking the integration, 1 over 2 times 2 is 1 times r200, and the integration of 1 is x. The integration of, this is minus, the integration of 2t is 1 over 2 sine 2t, integration from 2 to 2 pi, and substitute the value pi over 2 over and 0. So area is equal r square times pi over 2. So it is pi over 2 r square. This is the area of semicircle. As you know that the area of circle is pi r square. Check it out, number 3. Find the area of the ellipse whose equation is x squared over a squared plus y squared over b squared is equal 1. As we taken before, that the area of ellipse is equal, the area of ellipse is equal, the area of ellipse is equal as we know that the area of ellipse is equal a times b times pi. That means ab pi. We are going to prove this one. If there is an example is, or the question is options, we can choose this one. But as we do for the semicircle, at the example, we are doing to finding the area by checking it out 3. Find the area of the ellipse whose equation is x squared over a squared plus y squared over b squared equal 1. First of all, we must find the fraction of this ellipse. By finding the value of y, it becomes b over a square root of a squared minus x squared. This is the ellipse. To finding this area, we are taking only the first quarter from 0 to a and multiplied it by 4 because all of them, this part is equal this one and equal this one and equal this one. So the area of the ellipse, all of it, is equal 4 over b over a because b over a is a constant. Integration from 0 to a and square root of a squared minus x squared dx. As we do it at the example, we are using substitution to find this integration. By taking x is equal a cosine theta. If, as we do before, this is theta, this is x over a, and multiplying is become x is equal a cosine theta. And now from this one, we can find by squaring both sides, so it's become x squared is equal a squared cosine square theta. And by taking the derivative of x, is become derivative of x is equal a, and the derivative of cosine is minus sine d theta. And now when x is 0, the theta is pi over 2, and when x is a, the theta is 0. And now substituting all this information at the integration of area. So a is equal 4 over b, integration from pi over 2 to 0, because when x is 0, theta is pi over 2, and when x is a, theta is 0, square root of a square minus a square cosine square theta minus a sine theta d theta. And now we are cancelling this a with this a, so it becomes minus r 4b. Because we changed the interval of integration, so we must make the integration negative, or multiply the integration by negative. Square root of a square minus by taking a square as a common factor, it remains 1 minus cosine square theta times minus sine theta d theta. And now multiplying, minus by minus, it becomes 4b. And square root of a square is a, multiplying by b is 4ba. Integration from 0 to the pi over 2. 1 minus cosine square theta is sine square theta, sine theta d theta. And now a is equal 4b a square root of 0 from pi to the pi over 2. The square root of sine square is sine. Sine times sine is sine square. Is sine square d theta. And now, before we continuing this video, you must know that the area of the ellipse is equal. The area of ellipse is equal a times b times pi, or ab pi. A is equal 4ba, integration from 0 to the pi over 2 sine square d theta. As we know, the sine square is 1 over 2, 1 minus cosine 2 theta d theta. And now, cancelling this 2 with this 4 is remaining 2ba, and taking the integration of 1 for d theta is theta minus the integration of cosine 2 theta is 1 over 2 sine 2 theta from 0 to the pi over 2. And now substitute pi over 2 and 0. So it becomes a is equal to ba, when we are substituting pi over 2 in place of theta, it's become pi over 2 minus 1 over 2 sine 2 times pi over 2 minus, when we substituting 0, it's become minus 2ab 0 minus 1 over 2 sine 0. And simplifying, it become a is equal ba pi. This is the area of ellipse. Question: which of the following is true for the given graph? For this graph, which of this one is true? As you know that this area is from 0 to the 3, after that from 3 to the 4. From 0 to the 3, f of x is over gx. F of x is over gx. And from 3 to the 4, g of x is over f of x. So the integration b, or the area b, from 0 to the 3, f of x minus gx dx, plus the integration from 3 to 4, g of x minus f of x dx. As you can see here, that the D is a correct answer. D is a correct answer. Question: if f of x is equal x squared minus 2 and g of x is equal minus x cubed, find the area of the shadowed region. As you can see, we have two intervals, one of them from 0 to 1 and the second one from 1 to 2. At the interval 0, 1, the graph of the gx is over the graph of the f of x. That means the value of gx is bigger than the value of f of x. And at interval 1, 2, as you can see, the graph of f of x is over the graph of the g of x. Because of that, the integration is f of x is minus g of x. By replacing the value of gx and f of x, a is equal integration from 0 to 1 minus x cubed minus x squared plus 2, and from 1 to 2 is x squared minus 2 plus x cubed. Integration, the integration of minus x cubed is minus x to the power 4 over 4. The integration of minus x squared is minus x cubed over 3, plus the integration of 2 is 2x from 0 to 1. Here the integration of x squared is x cubed over 3. The integration of 2 is minus 2x, plus the integration of x cubed is x to the power 4 over 5. And now replace the value of 1 and 0 become 1 to the power 4 is 1 over 4, 1 in place, 1 cube is 1 over 3, plus 2 times 1 is 2. When we are replacing the 0, all of them is 0. So plus, and the 2 cube is 8 over 3, minus 2 times 2 is 4, plus 1 to the power 4 is 1 over 4, and 0.5 or 66 over 12. This is the area between these two graphs. Find the area of the shadowed region. As you can see here, we have two functions. One of them, y is equal 1, which is a constant function, and the second one, y is equal cosine square x from 0 to the pi. At all the interval, 1 is bigger than y, bigger than cosine square. So the area is equal integration from 0 to the pi 1 minus cosine square dx. Because we haven't any rule for that, we must change 1 of cosine square to the sine. So it is become area is equal from 0 to pi sine square dx. And now, because for the sine square we haven't any rule in this graph, so we must change this one as sine square x is equal 1 over 2 1 minus cosine 2x. And now take the integration 1 over 2. The integration of 1 is x, and the integration of cosine 2x is 1 over 2 sine 2x, and replace pi. It becomes 1 over 2 pi minus 1 over 2 sine 2 pi. When we are substituting 0, it's become 0 minus sine 0, and a is equal 1 over 2 pi minus 0 minus 1 over 2 0 minus 0, so it is a is pi over 2, the area between these two graphs. Question number 18. Find the area of the region bounded by the graph of x plus x y squared equals 0 and x equals 3y squared equal to 2. This is the graph of two functions. First of all, find x in terms of y. In the first equation, x is equal minus y squared. In the second equation, x is equal 2 minus 3y squared. And now find x equal to x. That means find the intersection of these two graphs. As you can see here, the intersection of these two graphs is from minus 1 or minus 1. And now minus y squared equal to minus 3y squared. By taking 2 minus 3y squared from right to the left, minus y squared plus 3y squared is equal to 2y squared is equal 2, because minus y squared plus 3y squared, it is 2y squared plus 2, and dividing by 2, then y squared is equal 1, and taking square root for both sides, so y is equal plus or minus 1. And now we are taking the integration for y. So interval is from minus 1, 1. That means y is equal minus 1, y is equal 1. Then the area of between these two graphs is from area is equal absolute value of integration minus 1, 1. The first equation is x is equal minus y squared. That means minus y squared minus, and the second one is 2 minus y squared dy. And now opening this bracket and simplifying, area is equal absolute value of minus 1 integration from minus 1 to 1, 2y squared minus 2 dy. And now take the integration by dy. For dy, it's equal 2y squared is 2y cubed over 3 minus 2y, integration from minus 1 to 1, and the first time substitute 1 in place y, So it becomes 2 times 1 cube over 3 minus 2 times 1 minus, and now substituted minus 1 in place. Y is 2 minus y minus 1 cube over 3 minus 2 minus 1. And simplifying is become 8 over 3. Here we reach the end of the lesson. Thank you for listening. Please do not forget to subscribe the page, and if you have any question, write your comment and push like button. Thank you for listening, and goodbye.